Good afternoon, everyone. My name is Dean Cox. As you can tell, I'm not from this country originally, from the UK. Been in the aerospace industry about 30 years now. Started my life off at Airbus in the UK as a wing designer, and been fortunate enough to work for many aerospace companies in my career. I joined the Collinear Group about 2.5 years ago, and working with them on various projects, airworthiness and certification. But most recently, I've been heavily involved in some of the Industry 4.0 initiatives, so hoping to kind of bring some of that to the table today.
My career, get a chance to read the bio, some of the details, but I've been lucky to work on a lot of new things, a lot of innovations and ideas or technology, including 777 ETOPS, overflight water out of the box, supersonic compression technology for clean energy tech, and now automation and robots and lasers. As I tell my boys, I get to work on those, and they say, finally, something cool. So I've really enjoyed helping companies navigate some of the pitfalls, and hope to share some of those, some of that advice and some of those things with you guys today.
Yeah, I'm Erik Lund. I'm currently CEO of FEV Lund and also CTO of FEV Automation and Composites. I'm lucky to have worked for 20 plus years with a great group of people at FEV Lund, and essentially get to help guide and fill the hopper of good automation projects for our team of roughly 45 engineers. I've worked in essentially automation anywhere from aerospace, semiconductors, heavy movable structures. Essentially come to the conclusion that I'll do anything that moves or flows, and so I think it's definitely an organization that looks for challenges for sure.
Hi everyone, my name is Jonathan Schwedhelm. I'm the Director of Engineering at FEV Lund. Got about 15 or so years of engineering experience. My background is in mechanical engineering, and I've been at FEV Lund for the last 10.5 years. So I've had a lot of opportunity to be on the forefront of cool automation development and a lot of the neat projects that we've been doing to assist our customers, ranging from aerospace to startups to medical device companies and everything kind of in between. Excited to be here today and teach you guys a little bit about automation and some of the lessons we've learned over the years. Well, great. So as introduced, my name is Jonathan. I'm with FEV Lund, and FEV Lund is a unique company with decades of experience working with our customers to bring unique automation projects and process development from concept sketches to world-class production machinery. When Hans came to us, I guess Hans and Erik came to us about this meetup, we had a lot of different ideas of what we wanted to cover in this meeting, so it was kind of hard to narrow it down. But since this is the first of the meetings kind of centric around robotics and automation, I thought it'd be kind of interesting to kind of look back at the history of robotics and automation and how it's changed the landscape of manufacturing, as well as some examples of some of the ways that we at FEV Lund have had great success in changing the way that large industries can develop their processes for automation. So automation and robots, those terms kind of get intermingled quite a bit when people are talking about it. Excuse me, turn off. So the term robot is used because it's an easy and universal way for people to kind of describe a machine that does something a human would otherwise do. And when people who don't work in automation hear the term robot, it's easy for them to think about those brightly colored machines with grippers, welders, and other pieces of equipment bolted onto them, moving around in a factory. But really, automation as a whole is a lot more than just those multi-axis kind of industrial robots. While they're a really adaptable and important tool, they're really only one part of the story. When we say automation, what we really mean is the use of machine elements and their control systems working together to perform a task and be adaptable. And when we say an industrial robot, what we really mean are those multi-axis machines that are flexible, adaptable, teachable in their functions and motion. So to us at FEV Lund, automation projects are a lot more than just the machine elements and the control systems. In order for automation to make the most significant impacts, customers and their experts, along with the automation suppliers like us, have to work together to make the technological leaps that industry needs. So if you look back, factories have had machines doing tasks to assist humans for a long time. But in the beginning, these machines were really single task oriented and certainly not programmable to have their motions easily adapted as processes needed to change. They were like cam operated or just had switches that made them move back and forth as the process continued. The birth of automation, kind of as we know it today, didn't really happen until the 1940s and 1950s, when engineers started to mix computers and machines to obtain the flexibility needed and address the needs of companies who wanted to implement that kind of automation. So the first example of mixing computers and machines was with the Cincinnati Millicon Hydrotel 3-axis mill. So these days, CNC milling is a pretty ubiquitous term. It's used all over the place in manufacturing, and it's kind of like the most basic piece of automation. And while milling machine techniques like turning and milling were first invented in like the 18th century, so like the mid 1700s, and servo motors, which are often used to control those kinds of machines nowadays, have been around since 1834. It wasn't until the late 1940s and early 1950s that engineers adapted these machines to have computer controls to perform the kind of motion that humans couldn't easily do. And this really invented the process of computer numeric control, or CNC, which is ubiquitous in manufacturing today. It was these inventions that really opened the doors to the kinds of machines that we think about today when we talk about factory automation and robots. So the first patented machine which resembles modern automation was concepted in the 1950s and was coined the Programmable Article Transfer Machine, which is kind of a mouthful. They weren't good at acronyms back then, I guess. But it was a feedback-controlled, servo-driven 3-axis machine for a pick-and-place application. And at the time, pick-and-place machines certainly existed, things that picked up something from position A and moved it to position B. But what was unique about this machine was that it was programmable and flexible, so they could easily adapt it and reprogram it to each new set of operating requirements. So this really addressed a problem that we consider pretty trivial and solvable today. Automation or robots like this exist in a lot of different forms. There's scarab robots, multi-axis gantries, large multiple-axis robots. Those are all off-the-shelf like solutions that you can basically pick up a catalog and order it and get it to do what you need it to do with a little bit of programming. But this machine was novel back then, and it really led to the first industrial robot and all the huge advancements in manufacturing over the following decades. So the inventor of this machine partnered with another engineer entrepreneur, and together they started this company called Unimation, and it was based in the East Coast of the US. And at the time, the US auto industry was already really heavily invested in the concept of industrial robots and automation. So eventually, Unimation found a pretty viable industrial application for their robots in GM's die casting foundry, helping move parts around and in and out of dangerous machines or hot machines. And not too long after that, those same robots were used in spot welding operations on the assembly lines. So eventually, one GM plant, which really invested heavily in these robots, was able to produce over twice the number of cars of the next most efficient factory by 1969. This was really huge. It was really a huge game changer. So factories all around the world kind of caught wind of this and the concept of these industrial robots, and it really became a hot commodity. And people really began to change the way that they thought about processes and adapt them for automation. I wasn't really able to find a whole lot of detail about like the specs of those early robots, but if you search YouTube videos for Unimation or the term Unimat, there's some plenty of videos to watch of these robots like serving cups of wine and coffee to people, as well as them in actual factories. So they were kind of a gimmick as well as a really useful thing at the time. But what I was able to find is that the Japanese auto industry really took a huge liking, just like the US did, to these kinds of machines. And they really started implementing them quickly as well. And by today's standards, those machines were really nothing special. They had like a 12-kilogram payload and a really big footprint for what they were, and weighed like 1.6 tons. And to me, the most amazing fact about them is each one of those in Japan costs nearly $750,000 in today's money, which is like crazy because comparatively today, the same payload and reach robot, but one with like even more motion capabilities, can be purchased for less than $50,000. And there's lots of really small, high-quality industrial robots from trusted brands that can be purchased for less than the price of a used car, like $8,000 or $9,000. So you can see how industry has really changed as far as capabilities for price. So from that brief history lesson, it's pretty obvious that the demand for industrial robots and automation is huge. This advancement really relies on companies innovating and pushing the technological and physical limits to create machines and adapt existing processes to meet these needs. So I want to spend a few minutes talking about some of the common reasons why tasks are automated, as well as some of the perceived hurdles that we see our customers have, which are stopping them from automating. So most of the reasons to automate are pretty obvious and widely discussed. Machines can be designed and programmed to do things better than humans in many ways. Along with that, robots can really be designed to go places and do things that are not safe for humans to do. Along with that, one of the hugest drivers, obviously, in automation revolves around cost savings and making better products. So this can come in many different forms. Productivity improvements like increased production rates, having better lead times compared to your competitors, reductions in raw material usage or scrap generation, and just general increases in consistency so that you don't have as much of a QA problem. Of course, along with that, automation can be useful for reducing headcount and thus personnel costs. So one of the misguided reasons that we see people choosing automation is from a salesperson walking through a factory, dreaming up ways to sell products and solutions, then pushing those solutions to that customer. And obviously, we think it's a really great idea to invite people to your facility to come in and give you ideas and listen to what your problems are, but it's always a good idea to have a good structure around those visits to perform your due diligence before jumping in, especially if you're new to automation and process development. So along with that, the top reasons that companies don't pursue automation really vary. In working with our customers, these are some of the top reasons I kind of put together. Obviously, upfront cost is a big thing. Not all processes are really that easy to automate, and the prices can be certainly a stumbling block to get over. But along with that, capital equipment always isn't available when needed, especially for new companies. And it's a pretty scary thing to write a big check for a piece of equipment or technology that's still kind of unproven or new to you, especially if the supplier is new to you. One of the other big stumbling blocks is the perceived lack of flexibility. So automation is obviously pretty synonymous with these really large fixed installations that require reinforced foundations, major construction, and they can take up a lot of valuable real estate while you're still just assembling them and pulling them into production. Those are all kind of things that a lot of people consider to be sunk costs. But that doesn't always have to be the case, because you can design automation to be able to be retrofitted, be flexible, or you can always reuse. If you buy a specific robot, you can always kind of continue to use it in new applications, assuming those applications are conducive to using a robot. Along with that, some industries, there's a lot of negative connotation around automation displacing jobs. That could be an issue. But two areas that I really want to focus on are cases where there's a perception that the right technology doesn't exist, and companies who lack experience with automation and thus don't really have a strong culture to support it. So just because the right technology doesn't exist or is perceived not to exist, with the right supplier, there's really no reason why you can't be part of making it exist if you see a spot for it in your company. And you get the benefit of being a part of that process and really owning it. And for those new to automation, a really good supplier should be able to lead you from start to finish on those kinds of projects and really help build a culture for automation and those kind of technical advancements. So that brings the question, how do you successfully bring automation from idea to production? Like we said before, we get a lot of different customers in different industries with different levels of experience and different problems. And I kind of have the general following few little bullet points of advice. So obviously, first, you always want to identify your goals. A lot of companies think about just automating it, replacing what a human is otherwise doing. Or they look at it as we have a whole new process that we need to develop, or somewhere in between. You need to know how involved you want to be or how involved you can be. You need to know whether you are or ready to write a specification. You don't need to get attached to any solution right off the bat. You really need to look at a broad range of potential solutions and evaluate them closely. And obviously, you should really do your research to get to know your potential automation suppliers and really consider ones, in my opinion, that have experience adapting processes versus just responding with a solution to a specific RFQ. And I've kind of been alluding to this a couple times. The most important thing in automating a task, if you want to really kind of change the industry or do something cool, is to not just copy what humans are currently doing. You need to look at your process and adapt it and learn how to change that so that automation can be even more successful. So I think right now, I'd like to hand it over to Erik, who's going to talk a little bit about how we like to encourage our customers to think outside the normal process, which allows us to work better with them and make industry-changing advancements in automation. So the next few slides, we'll cover that, and then after that, we'll talk through a few little case studies of some things we've learned along the way. So Erik, you want to take over?
Yeah, thanks, Jonathan. Can you guys hear an echo? Oh, I think it was Jonathan. So, Jonathan said something that I think we hear over and over again. Somebody comes to us and says they need a robot, which is to us kind of short for saying, I'm not sure what I need, but I want something that's not a human or something that's automated. And so a lot of times, as he's saying, they don't truly understand what they need, how they want to implement it, how they want to qualify it, how it fits their overall facility, their process. So a lot of times, we'll have to kind of back up and start in that kind of how do we specify what it is that you want to do before we get into what type of automation they need. I'm sure we all get into the RFI phase, which is, a customer like Boeing, which, with all good intentions, but an RFI to us has become the classic request for free ideas. Essentially, it's that phase of a process or project that a customer will not really know what they want, but they'll toss it out to industry and see what comes back and essentially try to use that to formulate what an RFQ might have in it. We've always been very successful at backing up to that kind of first principle. What's the business case? Why are we trying to do this? What are the paths toward getting it to a qualified process? Do we have to automate everything? Are there things that we should automate that you're not essentially considering? So a lot of times, the customers and other people within the industry are going to be providing help for us. So if you click to the next slide there, Jonathan. So this kind of, I guess, goes through, what we'll say is a good example of some of the things that we've done. Early on, in Boeing's composite development for 787, we spent a lot of time working with them on identifying, what composite goals they had. They came out, showed us the big chart and said, well, here's the world's, here's aerospace's use of composites per pound. Here's what it's going to look like after 787. Here's what it's going to look like after A350 and so forth. And so obviously there was a big step function in what was going on there on what it was going to cost to do production the way that 777 had done production, which was just kind of dipping its toe into the composites world. Basically they identified that there wasn't processes out there, and so what we did is we sat down with a lot of the people at Boeing, all the way from the people who were engineering the plane to the people who were in charge of doing the equipment purchases, and then to the BR&T people, and then all the way to the quality people. At some point we knew we were going to be developing a process that didn't have standard specifications or way of qualifying the process. So, it really, all those people had an influence on how we did the automation, whether it was how we did the inspection systems or how we generally did the adjustments and the qualifications of the machines. So really, even within that realm, we saw, hey, Boeing had its experts, we had our experts, but there was things we wanted to do that weren't expertise that we had within those groups. And so we even looked at, do we need to go outside to trusted suppliers, trusted consultants? Do we need bigger spaces, that type of thing? So I think in general, what we look at is if you really want to get in and do the things that revolutionize an industry, you sometimes have to have that humility to understand that at some point there might be tools that exist, there might be intelligence that exists, but there might be things that you have to go invent or partner with to get to the solution that you're looking for. Go ahead, Jonathan.
Okay, so I think that was a good little overview, and just to show some fun technology at the same time. One of the things that we like to think about all the time here when we're developing new technologies and new machines is the power of proof of concept. So a lot of times customers come to us, hold on, I'll pause this. Customers come to us with saying like, hey, do you think this can be done? Or what would it cost to figure this out? And sometimes you just really have to go back to basics and make a really small little test bed and start with step 1 and 2, figure out what's possible before you make a whole big multi-million-dollar machine. So the next few slides are just kind of really simple demonstrations of a technology that went from really what we call like a breadboard to like a full industrial production machine. So this is technology that's used to lay up the wing skins for the 787. At this point, yeah, I'll just let the slides go, and I think we'll go from there and hand it over to a co-linear at the end of their presentation. I apologize, the second video doesn't have any audio, so just like play some music in your head or something. So what we were trying to go ahead,
Sorry,
Eric.
Jonathan. Okay, so just to get some context, we had essentially a case study where we were trying to develop a new manufacturing line for some of back when Boeing was interested in obviously doing a new airplane, and the hope was could we develop the initial enabling technology that would allow us to essentially feed a line that was downstream from this process. And so even though this looked relatively simple, the intent here was that this would feed a multi-million dollar, essentially assembly process. And so we had this test here, which is technology that we have, but we also had 2 or 3 other small little enablers. And what we could do is as you would expect, we would retire risk on some of those critical items, and then knowing that there was a lot of other things that would eventually fill around those critical key technologies. But the intent was, how do we walk to greatness with essentially a retiring risk along the way without spending, $10 million getting there? So from that single lane 1.5 inch piece of composite, this is an example of how that comes together, where now we're doing 19 lanes, but essentially before we get to here, we've essentially baselined and understood, all the physics that are associated with each of the 19 lanes. So even though this technology that we're allowed to show you here is over 6 years old, like you say, it still kind of outlines, that single lane testing for this assembly was also done back 8 years ago. So that was a machine that we call Slalom, and we have 3 of those machines at Mitsubishi Heavy Industries, and so the 3 machines we deliver actually produce all the wing skins for 787, and essentially made the 8 traditional contoured tape laminating machines that MHI had originally purchased from, unfortunately, our now sister company. Those are now all obsolete, or at least we're doing essentially the work of what they had planned for 10 of those machines to do. So the intent there was obviously we wanted to better utilize the tooling and the space in the clean room for composite manufacturing, as well as provide a machine that had better output.
Cool. All right, Aaron and Dean, you want to take over?
Is Aaron on mute?
Yes, I am on mute. But am I sharing my intro slide?
Yes.
Yes, I can see it.
Okay. Thanks, Hans, for organizing this. And one thing I'll say up front, when Dean and I were thinking about how to make this memorable and valuable, We wanted to play with the stages of development theme to kind of keep it fun and add a little entertainment. So forgive us if we've stretched that comparison a little thin, but that's our contribution to this little webinar. We're not the robot experts. People go to Lund to make their dreams come true. People come to us to say, why are my dreams shattered? Why are they broken? And please fix them. And so we don't tell folks how to design the perfect robot, but we do have experience in introducing new technology and innovative ideas to large, established, and especially heavily regulated industries like aviation, Boeing, energy sector, et cetera. And like I said, we're usually called upon when things are going poorly. So what we wanted to focus on is kind of sharing some advice ahead of making mistakes, and the advice we give to the community to avoid those mistakes at the different stages. And this really applies to a lot of new technology, not just automation. Let's see, get the, there we go. So infancy. The introduction of innovation really requires a willing and nurturing home. You really need somebody with a vision and the willingness to take a chance and to be there as you are building the development, as you are introducing the innovation and new technology. If you don't have the right home, if you don't have a nurturing environment, if somebody's just expecting your new baby to run and drive a car, you're not going to fit in the family. And where that really comes from echoes some of the things that Erik and Jonathan said, which is requirements. I can't tell you how many times we have seen problems that always start with poorly defined requirements, requirements that don't bring all the right people into the room. And it's not just technical requirements like speed or precision or things like that, but really regulatory requirements and culture as well, sort of the workplace way things are done by people, for people. And there is learning in each of those areas that come at a price if you don't work those out ahead of time. Many times the innovator is not an expert in certification or industry regulation, and they don't even know the right questions to ask. And a lot of time the customer is not offering all the right pieces. They're working a bit in seclusion. They're taking a chance on technology. They want to advertise far and wide if it fails. And so getting all the requirements is very, very important. So requirements. The other thing is if you are working with your customer, you can get a lot of good requirements, but you haven't talked to enough people until you hear from the people that have to approve what you've made or what you're making, and they understand the details. And certification compliance is usually an afterthought when programs are introduced and new ways of thinking about things or doing things or worked on. Engineers hate it. And hate thinking about all the compliance and certification, and that's not foremost on their minds. Another quality of a good home is understanding that there is going to be support and constant attention early on. You'll need people in place. You'll need a lot of attention to the detail. You will not just install and walk away or just even have just regular visits. It's very, all the things that can go wrong in automation and all the ways that the process was not defined early on that you find when you're actually operating in an industrial environment really come out. And so if you undersell this stage, your relationship's going to be strained. The doubters will come out of the woodwork and will make life difficult. So finding the right home is really key in the first introduction phase. So during adolescence, this is, I have two boys and going through this phase myself. The opportunities are endless. They can be astronauts, they can be firemen, they can be president, they can be anything they want to be, and that can lead to a lot of distraction. And the part that usually companies come to us, or industry comes to us and says they're disappointed is you've demonstrated some value and potential in some early demonstrations, and there's growing interest, and folks are starting to generate other possibilities. But you're not yet done with your development. This is not a fun stage because we have to be a disparager of distraction. And some of the catchphrases I find myself saying is you need to feed the trunk of the tree, not get caught out on a limb. You want to do work that builds the development and not just going after a subset of application. When I was involved with the supersonic compression technology, we had interest in from the military on missiles, on compressing hydrogen, on refrigerants, tons of neat applications for this technology, but they were all too specific and too niche for supporting the basic development. And we really had to be disciplined in making sure that we weren't distracted with a one-off application. And that's sometimes really hard when that's where the money is. So I won't say it's an easy decision when faced with those for new, struggling innovators in big industry. The other pitfall in this stage is that you have to really be careful about overselling readiness and managing expectations. This is seen when you are successful in a limited lab or controlled environment, and everybody is talking about going to production scale or factory deployment, and your customer wants it to be ready. They don't want to hear they have to spend X more $1 million. You want it to be ready. Your board or support team doesn't want to hear it's going to take X more $1 million. But if you get big too soon, you're going to lose credibility when you have to own up to reality and scale back. And example of this is when we had a prototype that we didn't, we demonstrated some success. We didn't even have the manuals for it. And then we started talking about, training and troubleshooting and a factory layout, and ISO 9000 certification. And we got really excited really fast. But our moment of truth was when somebody told us how many people we'd have to fill this factory and staff it. And we couldn't hire 50 qualified detailed technical people a year after year. That's kind of the moment the cold water got dumped on us. So really want to make sure you're scaling back the expectations and the limits. Everybody wants to get rid of the curfew, but adolescence is truly getting experience without lack of oversight or no oversight. The other pitfall of this stage is when you're working with a customer, as I said before, before this, you're a bit isolated and a little bit under wraps. Probably you're not advertising to the entire industry or company that you're working on some for fear of failure. The bigger the company, the more detractors you potentially have fighting for the same dollars. And what we've really found is this is where the regulatory requirements show up and become a huge requirements adder that you never thought about, and have to go back and add tons of support around the technology. Many times it doesn't even relate to the technology, it relates to safety or confirmation that it won't hurt the part or hurt people, things that really aren't specific to your technology. So requirements, again, making sure you're talking to the right people at the right time is key. So I'll turn it over to Dean now to talk about what happens after you get into the workplace, after you get your first paying gig.
Thank you, Aaron. So I'm going to transition us from adolescence to adulthood here. So as adults, we finally get to experience life without the guardrails in place. So the first thing I was going to talk about here is it's not about me. I have to consider others. These are things that as we become an adult ring true. What we quickly learn is that as an adolescent, it was really all about me. We were extremely protected in our small worlds. And like adulthood in industry, as it matures into Industry 4.0, we know that robots are valuable and perform core functions. However, they form part of an overall larger infrastructure. So we're all pieces in the puzzle. Integration is extremely valuable. One thing you have to note is that integration is really, really hard to do. You have to learn to play nice with others. There's enormous value in having connected systems, data, and models. And as we model these systems, we're able then to predict trends, able to forecast outcomes based on various scenarios the complex data systems give us, along with using artificial intelligence to add even more value. Our customers are craving these type of models and these integrations. And one thing I hear pretty much every day is when we show them what we can do is, oh, I want that. But they really need to really understand what it takes to kind of implement that. And it's not something that can be done overnight. It takes a lot of thought and action to be able to put in place. Language barriers are also very difficult to overcome. So we need to make sure that the languages our robots and data systems speak are unified and that they allow these systems to interact with each other, making it almost seamless. This leads to improved integration, which makes that integration a lot easier. But that's not always the kind of thing we think about up front when we're designing the system. So thinking about how they're going to talk to various other systems or what other connectivity they may need in future is very important. So the part that if I knew then what I know now, so I assume that at some point everyone's assembled some IKEA furniture. Anyone who has assembled IKEA furniture will understand that the second project is much easier than the first one. So once you understand that instruction style and how the standardized components work, it's much, much easier. The more you build, the better you become, as long as you can find that missing part. Evolution is essential to survive. And the next time we design a system, we evolve it to remove waste or inefficiencies and also take advantage of new developments in technology, like the Internet of Things, RFID, camera systems, proximity systems, monitoring systems, health detection, and health management. So we need to keep reinventing ourselves and keep evolving to make sure we're as efficient as possible. And that means a plan for retirement. So at some point there will come a time that the technology has evolved and kind of got to its limits, and you need to make room for the next generation. So investment in new technology is critical, something you should always be looking at. Make sure you ensure that you increase your efficiency and the value that you bring by introducing the next generation of robotic or control system. It can be a make or break for you in a competitive environment. So something really to consider. So you must learn to adapt to your ecosystem. You must change your perspective or tweak your code in order to keep operating as efficiently as possible. We can move to the next page, please. Thank you. So I guess this is a bit of a time to give some of the young people in the crowd just getting started in their career or relatively new to the industry some advice. So it's true, not nobody listens to their parents. Sometimes it's easier to talk to somebody outside the family. We all had that favorite aunt or uncle that we may want to confide in. So get outside experience. As you get older, you gain wisdom. And one thing we need help to do, and we need to really help our younger and typically smarter engineers, programmers, and developers is to bring in experience, right? So by bringing in people who have been around the block a few times, they've already made their mistakes, they've learned, and they've got scars to prove it. So get as many experienced professionals on board as part of the team as possible. Some key advice there. Me personally, I've watched many YouTube videos on how to repair a hole in a piece of drywall. But you quickly learn that when you actually do that repair yourself, it's not as easy as they made it look on the video. There's a certain amount of skill needed, and you really only learn to do that by experience. So seeing it done is not the same as having done it. And last but no means least, you get what you pay for. Having the right people to offer you advice and guidance is important. Oh, sorry, thank you. You need to make sure that you invest in the right people with the right experience, and you can save yourself a lot of money in the long run. So an independent review from somebody outside is always refreshing. As I said before, sometimes it's easier to talk to someone outside the family. I think bringing somebody in new who has experience really does bring that additional value, and it's worth it in the long term. Go to the next slide, please. So obviously, some people are concerned that they will be replaced by robots. I think that humans will always have a place in industry, or at least for the near future. You cannot program a robot to exceed expectations. Pretty good statement there. Me myself, I've been honored to work with some very smart people during my career with unique problem-solving capability. That's the one thing and one strong attribute that makes us human. And hopefully, we don't lose that ability to think for ourselves, and we increase creativity as technology evolves over time. So there's still room for us for us left. So I think that's really kind of all I had to say about the adulthood phase. I'd like to thank you very much for taking the time to listen to Aaron and I today. We're always available if you want to give us a call or drop us an email with any thoughts or questions you may have. We're happy to stick around and answer some questions from now on, but our contact details are on the screen. If you want to make note in there, please do give us a call anytime.
Thank you, Dean. We'll switch to the questions. I had a question, but Josh, you had a couple of questions. You want to ask them? Just turn on your microphone and camera if you want. You can just start with yours. Josh, he's still here. All right. I'll ask. Oh.
Josh, you're on mute.
No? Oh, all right.
Yeah, he's saying it's not working.
All right, I can ask the first two. I will get to your predictive content one. So in terms of the automation, so my question was how much of this is actually off the shelf? Like, do you just go to KUKA and any of the companies that build robots and buy this off the shelf and then you're just integrating it? Or is most of it still custom? And kind of related to that, and going into Josh's question, I guess, how do they work in a discrete work? How do the individual, let me see, it says most of the automation solutions that I've seen has each robot machine working as an individual discrete work cell. Has there been any focus on making systems of equipment that work as a group team? So
yeah, I can take a swing at answering these. So the first question about how much is off the shelf and how much is custom. It's actually pretty amazing over the last, I don't know, 6 or 8 years, the amount of products available off the shelf or with like minor customizations allowed from the factory is pretty amazing. So more and more we do see using off-the-shelf solutions. Obviously, they're generally a little easier to integrate. You don't have to do design work around making them do what you want. There's just a lot of repeated functions of automation, like clamping, gripping, moving. So for many of those applications, we're able to find off-the-shelf parts that do what we want. But there's always the bits and bobs that are needed to tie everything together. And there's, depending on the application, a lot of specific things needed. So long answer short, it really depends on the machine and the application. When you see robots in factories and stickers on them with names like KUKA, FANUC, all those kind of big names, Goodle, those are pretty much off-the-shelf parts, and people are integrating them. It'll be all just the shiny aluminum and painted steel parts. Those are the ones that are custom and kind of the things that tie it all together. And as far as discrete work cells versus equipment that kind of works together as a team, I think that's also a complicated question and a pretty good question. There has been a lot of consideration, especially in recent years, about this like collaborative robot concept, where there are maybe 2 robots working together hand in hand, one holding one part of a machine, the other holding the other, so that they can reach things that otherwise they wouldn't be able to reach, or robots handing parts from one to the other and carrying on. But the reality is, in a lot of really high production environments, those work cells that look pretty discrete are actually very connected. They have similar e-stops, like if one part of the line has to stop, the other one will have to stop, because they're so integrated as far as parts coming in and out, and they need to be timed together in order to keep all the downstream processes flowing correctly. But in general, especially when product is, or not product, but like technology is being developed, you see it's in such discrete work cells because that's a really easy way to break up the problem, right? You can say, over here, we need someone that designs something that does welding equipment. Over here, we need something that does the deburring. And sometimes it doesn't make sense for those to be the same thing. And that's just one of the things where it depends on the maturity of the customer and their willingness to take risk in designing their automation, kind of pushing the limits on what an individual cell can do.
Cool. Looks like Josh left. I was going to ask if he wants to see if he wants to ask his other question. I had a few. So the other one was related to regulations and regulatory requirements. So in aerospace, we have FAA. How much of that actually impacts your automation? Like, do you have to certify the robot, the whole system? Like, what's that process?
I can take that if needed. So a lot of the processes that we do within, like say, a manufacturing environment for Boeing, Boeing is required to certify their processes, and we will, a lot of the times we will work with them, but being slightly removed from we're producing machines that produce parts that go into a qualified airplane. So we are definitely not under the same qualification restrictions or requirements that Boeing is directly to the FAA. So our responsibilities are normally to Boeing, where they may have specifications that they surround a specification with, so they'll have a machine specification, and then they may have a general, how do you make parts that don't violate their requirement specification. So, normally those that are pertaining directly to how do you build planes so that they eventually can be FAA certified, those are usually very general or benign, or not necessarily even close to what the machine specifications are. So even though we're always cognizant of it, we need to use the proper contact materials. We need to not necessarily induce undetectable FOD or any of those other things that obviously make life crazy for Boeing. Most of the time, we can look at parts that are eventually inspected after our process. So essentially, if we don't want to create defects, but a lot of time those defects are within the Boeing safety net. They're detected prior to those going into final certification. So it's a little bit of a balance, but it's definitely not nearly what Boeing is going through for that final product.
Okay. So
a little slight other thing to add that's kind of interesting to note is, so a lot of times the good key in that is having your machine QA the parts as they're made. It really, if you can basically qualify your qualifying agent, or like the parts of your machine that prove that you're doing the right thing, it makes the job a lot easier. So there's a lot of work that goes into making sure that how you're checking as you move along is grabbing the right things, and that makes the downstream approvals a lot easier to get through.
Yeah, and to add to that point, sometimes we're checking things to make sure that our machine is operating properly, but sometimes you have to put a different hat on and understand how to check things so that the quality people within the Boeing or Airbus or whoever are comfortable. So, a lot of times we want to know things about the automation that the qualification of the airplane doesn't care about. And so sometimes, as Jonathan says, you have to kind of put on a different hat and walk with different people.
Yeah, this is Aaron. I'll amplify on that. A lot of times we've had to change processes to add points of inspection or accommodate old-fashioned human checks. A human has to check that a human did something or check something. And so the process part of it, really, especially in regulatory environment, has to bend towards what the FAA is used to seeing. Many times it's easier to ask people like Lund to change the process a little bit than ask the FAA to change their certification a little bit. There are definitely places where there are challenges, and if the customer is doing their job correctly, they ask Lund for the right process so they can meet those inspection requirements and qualification requirements.
Cool. I see Josh came back. Josh, do you want to ask your question about the predictive? Try again.
Sure. I lost my chat log, so I can't really see what I wrote. But one thing that I was curious about was the comment that you made on doing the predictive content. And that's something that's been kind of interesting for me, is what you guys are doing to lower the ongoing cost of the machine by reducing preventative maintenance and stuff like that. And are there other types of predictive model-based simulations that you're using to lower those ongoing costs?
Yeah, I think I can take that one, Hans, if you don't mind. And actually, I could probably make this also answer your question that you asked about what are some examples of systems / things you've had to integrate with. So I'll see if I can answer both those in one answer. So to give you an example, scheduling. So as you build very complex machines, and when you build very complex parts, they're have many operations to build. There's obviously a master schedule you need to follow, and sometimes you get off master schedule for various reasons, for part shortages or the lack of resources available on that day to do the job, or some defect that needs to be fixed on the line, and that can have obviously knock-on effects. When you model all that together in the system, and you can include machines in that, you can then really understand all of the interactions, and then you can start predicting, okay, if I'm falling behind schedule here, what is the impact in 2 or 3 days? Okay, and then you can start working upstream with people who are responsible for those assembly lines or those part of the build, to make sure you're pooling together resources, skills, and focusing quality to resolve the right parts at the right time. So you may have 10,000 jobs that are scheduled to be done, but now your schedule's kind of gone out of whack a little bit. What are the ones I should be focused on? It takes a huge amount of human effort to kind of go through in Excel. It would take you days to kind of fathom that, but as is now modeled, you can then run a Monte Carlo analysis or a sensitivity analysis and say, okay, which are the best ones to go fix that problem. So certainly in a fabrication world, we would also tie that into the machines and seeing what their effectivity downtime is, their uptime, what their kind of health is, when they want to plan in predictive maintenance. So for instance, if in our system, the schedule, we say it takes 2 hours to machine a part, but we see over the last 20 parts, the machine actually only took 1 hour, then the schedule can then use some AI to say, okay, we see there's some saving here. We can reduce the critical chain within the business to make you more effective and actually reduce flow time. And you can also see certain gaps when you model. You can then develop your critical chain, and you can really see where the gaps are in the production schedule, and to say, okay, well, if I just had 2 more people in this area, or if I did 3 more jobs in this section and moved this work around a little bit, what efficiencies does that give you? And having all that model allows you to kind of have those answers within seconds, rather than days, months, and years that it took us previously to answer that. In terms of the systems that we use, a lot of our OEMs we work with have their own developed systems, because they're not necessarily things that you can go out and get on the market. So highly configured internal systems, and that also talk with your standard CATIAs and Dalmias and other kind of off-the-shelf larger systems. So Carlinia has a lot of experience in making systems talk to each other. So we spend a lot of our times trying to create APIs and other language kind of interfacing tools, allow data to be pooled into one kind of single source, and then extrapolated across the tool set to get the optimum result. So I'm not too sure if that fully answers your question, but if not, please let me know.
Oh, that's great. Thank you.
Great, thank you. Good question.
So just related to that, so if each machine makers coming up with their own system, are you, so you're a lot of the work just integration work, and how
Yeah,
much
I
of
mean,
this is everyone's doing their own, and how long does it typically take?
the larger companies are getting better. They're starting to speak common language formats now, so it makes it a lot easier to integrate. But yeah, a lot of the time, our full-time job is the integration of those systems. So we develop so one system, and I can't go into too much detail, but there's one system that a local manufacturer uses that's very, very complex and very, very difficult to get data out of. So in order to understand the outputs of that software, you need to be have a lot of experience using it and understand the intricacies of how it works to do some analysis. What we've done is we designed interfaces to that system that takes all that complex data and puts it into much more user. So we have people in user experience and user interface. We made sure that we can take that data and make it much simpler. So you don't need a 20-year experience guide to figure out the information and understand the data. You could do it with a relatively less experienced person by putting that interface in between the two tool sets. So a lot of the time we put tools on top of tools to make them easier to understand.
Cool.
Yeah, Hans, I got to throw in, it's unfortunate and somewhat comical how often we have to drive from spreadsheets, Excel spreadsheets. And folks are using Excel spreadsheets to translate their data to somebody else's spreadsheet, and you got to bring them together when you start integrating these systems.
So I have one last question here, and then I don't know if anybody else has any questions. So how, given this is all new, I mean, you guys have been doing this for a while. What is hiring for this type of skills like in the Seattle area in Washington? Are you finding it easy to find the skills, or like where are we? Where would you rate this our state in terms of where we are with all this robotics and automation?
I can jump
Well,
in.
I can. Do you want me to? We'll probably say the same thing anyway. So, I think in general, we have two sayings. One is we're not the industrial hub of the world. Obviously Seattle is. We'd like to think of ourselves as the center of the universe, but we know that there's definitely bigger industrial places in the Midwest and back east. So even Southern California, at some point we are a little disadvantaged to that, but then we're also at a little bit of a disadvantage to the fact that we seem to attract a lot of these big fish, the Microsofts, the Amazons, Blue Origin. There's definitely a bigger push for bringing in, some of those people who compete for the automation. So like I say, in general, we kind of think we have a little bit of a two-strike situation, and the one benefit is maybe that Boeing is a big player in this area, and they're starting to migrate toward more of a we build planes, we don't design machines to build planes. So we have a little bit of a benefit where the need is going up a little bit more, and Boeing isn't necessarily a competitor for some of those automation people. So companies like Collinear and Lund, we obviously benefit for Boeing having less of that talent base as well. But in general, I think Seattle on a whole, especially for wanting to hire young, great, motivated talent, people who really want to take the world by the tail. It's a bit of more of a challenge than it is, in Detroit, Michigan, I guess, where maybe the price of a house and other things like that aren't nearly as bad.
Right. All right. Well, looks like we have another question here. Karen, do you want to ask the question?
Hi. I've been am I audible?
Yes, we can hear you.
Yeah, I've been working on performance and compliance tracking, and what I find is the points of integration are a big challenge. Essentially, to what Dean's point, these things are very complex. All the internal control logic is unknown. All the different actuators and sensors that are being involved are unknown. So the only point of performance and compliance are the very interoperability endpoints that we end up working with. So I wanted to know what's the experience of having so many parts come together from different vendors that are interoperable and they are working fine when they are, but at some point there's a degradation. And how do you manage that as the entire system of systems operates? So that's basically the question there. Are there standards for measurements, telemetry, standards for interoperability and stuff like that? I'll just leave that question.
Who wants to take that one?
It's a great question, I think, and if you find someone who can do that, please let me know, because we will hire them tomorrow. It's you're right. It's super complicated, and every problem is different. I think the value that we as a company bring a lot of the time is we're able to we're agnostic in terms of the politics and the history behind the problem, so we can come in quickly and say, all right, just tell me, let's get the right people in the room and ask them the right questions, and let's tease that information out of them correctly, and let's go get those standards, and let's put them into a format that everyone can understand and agree. So being that not only are we technically integrating, we're integrating teams from across large businesses who don't necessarily work together. And yeah, we don't have all the answers, and sometimes we need to go find it out. But I think it's about asking the 5 whys, right? You need to really get to the core of the problem, and a lot of patience, a lot of empathy with the process is important. What you're describing is very frustrating and very, very difficult to do. It's about perseverance. You will get there. It just may take a long time, and you may have to. You may need to be a little bit political on how you do certain things, and you also need to give everyone a big hug and make sure that everyone's feeling good.
So how do you troubleshoot these problems? So for example, I guess Jonathan, the robot that you were showing, how many vendors are involved in that? Like, what do you do with when something goes wrong?
Well, so ultimately, we, as the designers of a piece of equipment like that, we are intimately familiar with it. And generally what we propose is having, for big machines and big installations like that, we'll try and have a service focal on site or nearby who's really familiar with the machine, and they can be the first hands on the ground or feet on the ground if there is a problem to support the customer. And they'll have generally a good idea of steps to take to troubleshoot, and when they need help, they can start kind of getting in touch with engineers locally to chase down the problem. But as far as how many different companies are involved with that, a machine like that has on the order of like 200,000 parts or more on them. More if you like, that would be like unique parts. More if you count down to like every single bolt and fastener, right? So a lot of the stuff it's bolts, fasteners, whatever, that's easy to get. Custom parts, we try and coach our clients on what spare parts they should have based on what we kind of know are typical failures, or just things that are long lead time that are worth having around if there is a failure point. But yeah, it's an interesting problem, certainly when you do have commercial off-the-shelf parts that fail unexpectedly. As the machine, I guess, suppliers, we're ultimately responsible for, especially if it's under warranty, then dealing with that and getting those parts replaced and back in the place or in the hands of the customer so that they're back running again.
So kind of going to Kieran's point, not having standards, he's making it more painful.
Yeah, so yeah, certainly a machine like that will have some control system. That's one of the interesting things with automation is there's many different suppliers of control systems. So like Siemens, Allen Bradley, those kind of companies, and very few of them can you really just pick a servo motor from another company and put it in. So if you have a Siemens system and your Siemens, the big motor from your machine fails and you don't have a spare, you're on the hook with Siemens and better hope they have one or that you can get one quickly. And some of these really big, complicated machines that we make, we push the limits so far that manufacturers have had to make custom motors specifically for us. We're working on a project right now that had some really specific requirements, and we actually got the first of their kind motors delivered to us. And there are no spares of those sitting around. guarantee of that. And they were like an 18-week lead time. So if we do carry a spare of those in stock, but if that one goes, it's 18 more weeks until you can get another one.
Oh wow, Karen, was that good?
Yeah, I think I think it's a great topic for because I'm working on software side of things, so I understand what you're talking about, Jonathan, where you have paths and the control system. So I work at the control systems level and above, and I understand the problem that some of those customers face when you have discrete control systems from various vendors, and then you have to look at it from a larger perspective of what's happening in the entire system, and you have to go across these control systems. Yeah, I understand that problem. Yeah.
Yeah, it's a unique thing, and it's pretty interesting to see how the industry has changed. Even in the last few years, control system suppliers are becoming more and more open, so that they realize it's a huge weakness when you can't communicate easily between control systems. And there's lots of big complex machines out there that you might want some really tight timing and some capabilities that's available in one product, but you need to have the CNC capabilities of another one. And merging to those together in the past has been very difficult, and now it's becoming easier and easier. So it's cool to see the transitions happen and people become more open. It opens up a lot of opportunities to do cooler, kind of more advanced work.
Yeah.
This sounds like an interesting meetup topic.
Yeah, it's a topic on its own.
Yeah. Well, I'll reach out. Maybe we can put something together.
Okay.
Is Jacob still here? Jacob has a question. Jacob, go ahead.
Yes. Hi, guys. Thanks for putting this on and sharing this information. My question ties in pretty close to what you guys were just talking about, the automation software. I see most people talk about PLCs and other closed source systems. What sort of future do you see with full programming languages, such as Python or C#, for example, to run the automation system itself, instead of building connectors or tools on top of tools like Dean was talking about?
So I think Jonathan.
Yeah, I can answer that.
Dean.
And maybe I see one of our controls engineers is on the call here too. Amanda can probably talk to this a little bit. But yeah, it's interesting. As I was kind of saying before, for a long time, control system suppliers were very closed off in what they allowed you to do with their systems. It was really like, here's our NC kernel, give it commands, do stuff, put in your kinematics, here's your machine. And we've seen a number of suppliers, specifically, I think B&R is one of the I guess most open ones, where you can basically write C# programs that run inside the control system, and you can do a lot of really cool stuff and really push your abilities to get to like the very base level of what the control system is trying to do to really tune your system and make the best product possible. So I think that's about. I guess the other answer to that is even Siemens is kind of seeing that as something they need to do, is start letting integrators like us get more tightly controlled access to what's actually going on in the kernel and their software. And so I think it's a discussion point that will kind of continue to evolve. But at this point, I would have to say, based on what I know, B&R is definitely the most open platform. And I think the name is escaping me right now. Backoff is also one that's a little bit more open as far as what it allows you to do and run your own kind of scripts and programs in the background. One of our companies that we work really closely with are B&R experts, and they have written basically really complex control system additions to the B&R platform, which are really powerful and pretty cool.
Cool. Any other questions? It looks like that's it. Thank you, guys. This was fantastic. Dean had to leave. He had a hard stop at 5. But thank you very much. This is awesome. The first of our technology and industry meetups. We'll spend more time talking about what's going on in the specific industries and try and bring them together here in Seattle. Cool. Thank you, guys.
Thank you, everyone.
Oh, wait. I So I have one point on C# and Python. Oh, it's from Josh. Josh, do you want to ask? That'll be the last one.
It actually wasn't really a question. Yeah, I'm a controls engineer as well. So with C# and Python, the reason that they're not used in the control systems is because those are managed languages specifically. So for the types of processes that these guys run and other people run, you really need to make sure that your time steps are the same. And that's where the PLCs and the embedded controllers really shine versus the managed languages. So,
yeah, that's a good point. Ultimately, you really need to have that tightly controlled timing and the systems controlling the communication between the different controllers, but having those background elements being powerful so that you can have a lot easier input and output from your system and more tight control as far as behavior is, where I think things will get pretty interesting.
Agreed. Yep.
Awesome. I think we need a follow-up on control systems.
If you don't mind,
very much.
If there's only one aspect, sorry about this, but maybe the control systems can actually classify sub 1 second time-based technology versus say 1 second and beyond technology. There's a different class of control systems that can use Python and C# and other languages, but definitely if it's sub 1 second and below, I think that's where it becomes difficult. That's basically, I would say, the approach. Thanks.
All right.
Yeah.
Anything else? As we'll call it an evening.
Thank you all.
Awesome. Thank you, guys.
Thank you, everyone.
All right.
Great information.
Thanks, guys. Bye.